students, today we are going to see remaining questions from JEE Mains 2026 Phase 1 January 21st morning shift. That remaining questions, let us check. Other two videos we have completed. Remaining questions, let us check in this video. Okay, now, which of the following compound is paramagnetic in nature? Actually, this question, it's very interesting. NiCO 4 times, NiCN 4 times 2 minus, NiCl 4 2 minus, and COH2O 3 plus. Okay, for this coordination compound, two main things we have to identify. That two main things can bring about all that hybridization, geometry, magnetic property, lower spin or higher spin complex, and Bohr magneton. All these 5 ideas, you can bring these two tricks. So what are those two main points to identify? First and foremost, what are the complex? Which complex we are going to find out that as according to the paramagnetic in nature? For that compound, you have to identify that. That means you have to find out the oxidation number. Find out oxidation state. Second one, you have to identify whether it is a weak field or strong field. Identify weak or strong field ligand. So these are the two main points can bring about hybridization and geometry. And the third one, what it is, magnetic property. And the next one, Bohr magneton, and lower spin or higher spin complexes. I just mentioned in a short way, lower spin or higher spin. Okay, come on, let us check each and every points as we discussed in this point. Okay, now the first one, NiCO 4 times. They did not mention any of this here. Okay, so that oxidation state at a 0. Okay, now here, carbonyl, that is actually it is a oxidation state. Here X, that means nickel, we have to identify the oxidation state. So X plus here 4 into 0, carbonyl compound at a 0 equal to 0. So X equal to 0, the oxidation state it is 0. And first point we found it. Second point, what it is, identify whether it is a weak field or strong field. Carbonyl compound, it is a strong field only. Okay, what it is called? Strong field ligand. Okay, strong field ligand means it can pair up the electrons in the orbitals. So can pair up the electrons. Okay, now let us check each and every point. Now nickel, when we are talking about nickel, atomic number 28. While writing electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Okay, so we can write it in a shortcut way. Argon 18, right? So argon here 4s2, 3d8. Okay, now according to that, we have to keep ready the empty orbitals to occupy the electrons. So that means here nickel CO 4 times, right? Okay, so like this, if it is available, means here 3d8, 4s2, 4p. So this is actually empty orbital. Now this is 3d, 5 orbitals we have to draw, right? 1, 2, 3, 4, and 5. Yes, this is 1 and this is 3. So empty orbitals we have to keep ready to accommodate that ligands. Okay, so here 8 electrons, right? So 1, 2, 3, 4, 5, and 6, 7, 8. And here what it is, 2 electrons. So now what happened? These 2 electrons can pair up the electrons because it is a strong field ligand. Strong field ligand means it can pair up the electrons. So automatically it goes and occupy the unpaired electrons to completely paired up. So that means it is completely filled orbitals. There is no unpaired electrons. So this is only the main points to note down. Okay, so there is no unpaired electrons. No, so unpaired electrons is not there, means it is a diamagnetic. If it is unpaired electrons, means it is a paramagnetic in nature. Now, so 10 electrons also come to here. Okay, so 3d and 4s orbital. Actually, here 4s and 4p are empty orbitals to put the ligands part. Okay, so that means here how many ligands are there? Here 4, no? So that means 1, 2, 3, and 4. So here 4 places also fills with that carbonyl compound, right? CO, 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 CO. Okay, both are capital letter only because carbonyl. CO small, if you put it, means it is a cobalt, you will get it. Right now, please, this is a small things to identify. Okay, now come on. Now this is actually, from here we can identify this is S and this is P3. So sp3 hybridization. Now hybridization is what it is? sp3. So sp3 means it is a tetrahedral. Tetrahedral. So they are asking in the question, they are asking only the paramagnetic or diamagnetic only. But as we come across this, we can identify all this. This will be helpful for what it is board as well as upcoming exams also, right? Okay. Now next one, geometry. Geometry only I just mentioned what it is. Tetrahedral. And the third one, what it is, magnetic property. This is what they asked. Okay, so magnetic property, there is no unpaired electrons. No unpaired electrons. Unpaired electrons. So naturally, it is a diamagnetic in nature. Diamagnetic in nature. Right? Got it? Okay, so that means NiCO4, it is not a paramagnetic. So that means, which is that another one? And the option will see. Okay, now next one, NiCN 4 times 2 minus, NiCl4 2 minus, COH2O 3 plus. Okay, let us check one by one. So which is a paramagnetic? Easily we can identify according to the same point. So nickel, already they mentioned that nickel cyanide also the same compound. Here NiCN 4 times 2 minus. Okay, now oxidation state of this compound, oxidation state. So oxidation state, what it is? In nickel, it is X plus Cn, it is -1 now. So 4 minus 1 equal to -2. So X minus 4 equal to -2. So X equal to +2 oxidation state. Now the second one, what it is? Weak field or strong field? The cyanide, it is a strong field ligand. Okay, cyanide, it is what it is? Strong field ligand. So strong field ligand, why do we go for it? Because it can pair up electrons. That is the reason, right? Can pair up electrons. Okay, now let us check with that nickel. It is 28. Just now we mentioned, right? So 28. Argon, it is 4s2 3d8. The two electrons will be relieved because oxidation state it is +2, no? So it is relieved. So it can pair up electrons, no? So that means we can go directly 3d 4s and 4p. Empty orbitals we have to keep because it has to accommodate that ligand for it. Okay, so here 5 orbitals, right? So 1 2 3 4 and 5. Okay, so this is 1 and this is 3. So in that you have to fill that ligands. Okay, now here in this point 3d 1 2 3 4 5 and 6 7 8. Okay, anyway it can pair the electrons, no? So directly we can go for it like this, pairing the electrons only. So here pair the electrons like this only, pair the electrons. So 3d8 and 4 is 0, 4p 0. But here what it is? Nickel CNI CN 4 times. So 2 minus, right? So that means here CN ligand it has to fill. Here CN and then here CN and then here CN. Okay. So that means here DSP2. So hybridization is what it is? DSP2. Hybridization, it is DSP2. So DSP2, it is a square planar, right? Okay, now they are asking magnetic property. Magnetic property, is there any unpaired electrons? So there is no unpaired electrons. No unpaired electrons. So no unpaired electrons means it is diamagnetic in nature. I hope you got the clarity. Okay, diamagnetic, magnetic in nature. Okay, now the next one, what it is? NiCl2 minus. NiCl 4 times 2 minus. This is what they mentioned, you know. Okay, oxidation state, the same idea only we are bringing. Oxidation state. Oxidation state. So oxidation state, what it is? X plus 4 minus 1. Okay, this is chloride, no? So -1 equal to here -2. So that means here what it is? Here also oxidation state, it is what it is? +2 only oxidation state. So X equal to +2 oxidation state. Okay, now this is weak field or strong field? Cl minus, it is actually weak field ligand. Okay, weak field ligand. So weak field ligand means whether it is can pair up or cannot pair up. It cannot pair up the electrons. Cannot pair up the electrons. So that means what we have to do, that same nickel, that nickel, it is 28 and argon 3s2 4d 3s2 3d8, sorry. 3s2, 3d, 8. Okay, that means minus 2, no. So 2 electrons it has released. So 8 electrons on it. It can pair up. No, it cannot pair up. So 3d, here 4s, 4p. So that means it cannot pair up. No, so let us write that atomic orbitals. So here 1, 2, 3, 4, and 5. Here 1 and here 3. 1, 2. Okay, now here orbitals, what it is? 8, no. So this is 8, no. So 1, 2, 3, 4, 5, 6, 7, and 8. So unpaired electrons, 2 unpaired electrons are there. Unpaired electrons, right? Okay, now here empty orbitals for what purpose? Fill the ligands. What is that ligand? Cl, Cl minus, Cl minus, Cl minus, Cl minus, chloride ion. Okay, how many actually? sp3 hybridization. Actually, what it is? sp3. S orbital, 3p orbital. So sp3 tetrahedral, you know very well. Okay, tetrahedral. So tetrahedral, it is a hybridization. Now we are going for what it is? Hybridization. It is tetrahedral. Tetrahedral. And magnetic property. What is it? Magnetic property here? Two unpaired electrons. Two unpaired electrons. So that is actually what it is. 100% it is a paramagnetic in nature. Magnetic in nature. Right now, here Bohr magneton. What it is? Root of, yeah, this is n equal to 2 because 2 unpaired electrons now. So n equal to 2. That Bohr magneton, it is n into n plus 2. So that means n equal to 2. Root of 2 into 2 plus 2. So how much it is? 4 2s are 8. Root of 8. So Bohr magneton, it is root 8. I hope you got the clarity now. Which is it? Which is the paramagnetic? NiCl 4 times 2 minus, it is a paramagnetic. Now let us check the last one, cobalt compound. It is CO. Here CO H2O 6 times 3 plus, right? That is what in the question it has mentioned. Okay, yes. Okay, now oxidation state. Oxidation. Why do we go for oxidation state? How many electrons it has to be relieved from that electronic configuration? So that is the reason. And weak field, strong field ligand. Why do we go for it? Whether it can pair up electrons or cannot pair up the electrons. So from that we can identify. That is what I just mentioned. 2 main points to bring out all the answers. Okay, so oxidation state. Right now here what it is? Oxidation state, cobalt X plus here 6 times. It is a neutral ligand. H2O, it is a neutral, right? So it's 0 equal to plus 3 oxidation. So X equal to plus 3 only. Okay, now atomic number of cobalt, it is 27, right? Cobalt, like this only. Carbonyl CO, big one, you can write it. But this is cobalt CO, small one. That is what starting as I mentioned. Okay, now this is 27. No atomic number, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d7, right? 4s2, 3d7, correct. 4s2, 3d7, completely filled orbital. No, that is what. 4s2, 3d7, one has to be completely filled. That is what I just mentioned. Okay, now here, so 3d8, if you put also, it is not completely filled. So better we can go for the lower points to completely filled. Okay, now how do we write it? Argon, short way. So argon, here 4s2, 3d7. Okay, how many electrons it has to lose? 3 plus 3 oxidation state now. So it is minus 3 electrons it has to lose. So that means here what it is? 3d6 only it is available because here 2 and here 1. So here come what it is? 3d6, 4s2, yeah, 4p and 4d. Okay, so empty orbitals it has to keep ready to why? To occupy the ligands. Okay, now here 5d orbitals, right? So 5 rooms will be available. 1, 2, 3, 4, and 5. Here 1 and here 3. 1, 2, 3, and here 5. Why no? Because ligands are 6 are there. That is what here CO H2O 6 times. That is what I just keep ready. 1, 2, 3, 4, and 5. Okay, now here how many electrons it has to be? 6. No. Okay, is it what it is? Strong field ligand or weak field ligand? H2O, it is a strong field ligand. What it is? Strong field ligand. So it can pair up electrons. Can pair up electrons. So that means electron here 1, 2, 3, 4, 5, and 6. But here what it is? It can pair up the electrons. No, so that means 1, 2, 3, 4, 5, 6. Okay, now that means here 2 unpaired electrons are there. So in that unpaired, sorry, what it is? Empty orbitals are there, not unpaired electrons. Here empty orbitals are there. In that empty orbitals, which one it will go and fill? Here H2O, it will go and fill. So H2O, H2O. Okay, these are all ligand. H2O ligand, it has to fill, right? H2O, H2O, H2O. How many? It is 6 are there. 1, 2, 3, 4, 5, 6. Okay, so 6 ligands, it has to be filled. So what is the hybridization you'll be getting here? D orbital 2 and S orbital 1 and P orbital 3. So D2sp3 hybridization, what it is? D2sp3. So D2sp3. So it is octahedral, right? Octahedral. Right now here magnetic property. So magnetic property, there is no unpaired electrons, no unpaired paired electrons. So no unpaired electrons means what it is? It is a diamagnetic. So diamagnetic, magnetic in nature. Right. Okay. Now I think you all got that all the answers. Now, which is the paramagnetic in nature? Only one compound, that is Cl minus compound, nickel Cl minus compound, right? So nickel NiCl 4 times 2 minus, right? I hope. Yes. Yes, we got it. All right. This is the point, right? So NiCl4 2 minus. This is only paramagnetic in nature. Yes, of course. I think you got an idea. How do we go for it? It is very interesting. Actually, this is 3 marks or 5 mark question in that board level they'll be asking. And this really interesting if you know that idea. This is very simple also. Okay, now which is the correct option? Paramagnetic in nature, Cl minus, Cl 4 times 2 minus. So option 3 is the correct option. So option 3 is the correct option. Hope you got the clarity. Come on, let us go to the next question. The next question. 1 gram of AB2 is dissolved in 50 gram of solvent such that delta TF equal to 0.689. When 1 gram of AB dissolved in 50 gram of the same solvent, delta TF, it is 1.176. Find the molar mass of AB2. Kf equal to 5 kg per mole. And AB2 and AB are non-electrolyte. Report this answer that is nearest to the integer. Okay, this is very simple. And it is a colligative property. They are asking about that, what it is. Find the molar mass of AB2. Right now here, I just write a complete data so that you will come to know the idea. So here 1 gram of AB2, AB2 dissolved in 50 grams of solvent. Okay, now that is delta TF for that 0.689. That is what it has mentioned now. 0. Okay, the next one, what it is? 1 gram of AB, another one. Okay, that is non-electrolyte. Both are non-electrolyte now. So this also 50 gram of solvent, same solvent, both of same solvent. They mentioned, same solvent. Okay, dissolved in the same solvent. Delta TF, freezing point. So that is 1.176. Okay, come on. Now we have to find out that molar mass of AB2. Okay, now what is the formula for delta TF? So that is depression and freezing point, right? Okay, so delta TF equal to KF into W2 into 1000. This is the formula, right? Divided by M2 into W1. Okay, so this is the formula we are going to use. Now we have to identify what it is, molar mass only. For that, we have to go for which is M1 and which is W1 and W2. We have to check it. Okay, W2, it is a mass of solute. Okay, W2, it is a mass of solute. Right now, W1, it is what it is, mass of solvent. They have mentioned everything, right? Mass of solvent. Right now here, mass of solute and mass of solvent. So mass of solute, it is 1 gram. They mentioned, 1 gram of AB2, 50 gram of solvent. 1 gram of AB, 50 gram, same solvent. So 1 gram, it is a solute, and 50 gram, it is a solvent. It has mentioned very clearly, dissolved in. So it is mentioned very clearly. Okay, now molar mass of AB2. So M only we don't know. TF they have given. TF also I just mentioned, TF for both. That's what data if we right now, it will be easy to apply. So this is the formula. So KF also they mentioned. What is that KF? It has mentioned 5 kg, 5 kg per mole. Right, that is what they mentioned. Now KF is equal to. Okay, now here AB2, it is what it is, 5 into 1 into 1000 divided by here 0. AB2 no 0.689 into what it is, 50. Solvent, it is 50. So how much it is? Here 5000 divided by, here when you multiply this, 34.45. So you will be getting what it is, around 145.137 gram per mole. see this one, the symbol, it's very important. Unit, it's very important because it's a molar mass, no, so naturally gram per mole. Okay, now let us go for this point also, AB also, molar mass of AB, molar mass of AB. So molar mass of AB, what it is? The same idea. 5 kg only. Kf it is 5 k, no. So 5 into 1, that is also 1 gram, into 1000 divided by 1.176. Data I provided and the same solvent, right? So 50 gram. Okay, so that means the same idea here. 5000 divided by, when you calculate these two, 58.8, please calculate it so that it will be. So you will get, what is the answer? We'll be getting around 85.034 gram per mole. Right. Okay. Now, for both the thing you got it now. ABT also, AB2 also you got it. AB also you got it. Okay. So here, now let me give that idea to identify which is AB2 and which is AB in that way. So here A and B, we can mention here small a and small b. Right. Well, okay. So first equation, A plus 2B. Why A plus 2B? Because first one, it is AB2. Right. So A plus 2B equal to 145.137, right? 137, what it is, gram per mole. Right. And the same way equation 2. So here A plus B equal to 85, right? 85.5034 here only the answer. Okay, gram per mole. Right. Now you have to subtract both the equation. So equation 1, equation 2 minus equation 1. Okay. Equation 2 minus equation 1. Right. Okay, so that means what you will be getting. So B equal to 145.137 minus 85.034. So you will be getting what it is, 60.103 gram per mole. Okay, that is B. Okay, B it is what it is, AB. Right. Now next one it is A. Now we have to identify A. So that means subtract B. This subtract. Okay, subtract B minus equation 2. Right. So that means here what it is, 85.034 minus 60.103. So you'll be getting 24.931 gram per mole. Right. Okay. So here very clearly I just mentioned here. First one, A, it is AB2, no. A, it is 24.931 gram per mole. And B, it is 60.1, not, yeah, 60.103 gram per mole. Okay, AB2, what it is? They are asking about AB2, no. So molar mass of AB2, it is 145.137 gram per mole. And AB, it is actually what it is, AB 85.3034 gram per mole. I hope you got the clear idea. This is the answer, integer, you can write it. Okay, so this is no option, integer way, you have to bring the answer. I hope you got the clarity about all these points. How do we bring out all these options? Actually, this is not required, only this point. If you are getting this AB2, it's more than enough. But I just bring all the idea because 5 mark question or 3 mark question, they may ask that what it is, physical chemistry problems, you will get nice marks. So that is what I just bring it to your notice. Yeah, come on, let us go to the next question. The next question, out of the following, how many compounds have tetrahedral geometry? Okay, now here in this point, NH4 plus Xe4 and nickel, NiCl4 2 minus platinum, PtCl4 2 minus Cu, NH3 4 times 2 plus BF3 and NiCO 4 times. See, in that first question, they asked magnetic in nature. Here they are asking about hybridization. So in that among which is having tetrahedral geometry, that we have to go for an integer way. Okay, they did not give any option, but we have to give the answer in an integer way. Right, come on. As we observe in the same idea only, I'm bringing here. So directly, I would like to give the answer here. So NH4, I just bring one by one. So at this point here, NH4 plus. So NH4 plus, it is sp3 hybridization. sp3 hybridization, it is tetrahedral. Tetrahedral. Right. Directly I'm giving the answer because you know already I have given the complete idea how to identify all this. First one hybridization, second one magnetic property, third one Bohr magneton, and lower spin, higher spin. Yeah, I have given all these points. Okay, so weak field ligand, strong field ligand. How do we identify oxidation state? In that way, you can identify all this. Right. Magnetic property also, of course. Right now, next one EXEF4. Okay. Xenon tetrafluoride. Okay, this is exceptional. Okay, yeah, already you have learned to know in that 11th grade. Okay, now come to this point. So what is this hybridization? So this is actually what it is. sp3d2. sp3d2, what it is? Square planar. Square planar. Right now, third one, what it is? NiCl4. Now, just we have gone through, right, this one. NiCl4, 2 minus, right? So this is actually what it is. NiCl4, it is tetrahedral, sp3 hybridization only. So please check it. This is tetrahedral. Tetrahedral. They are asking about tetrahedral. How many compounds are having tetrahedral? Okay, now this is platinum, PtCl4, 2 minus. Yeah, 2 minus. 2 minus. And this is, what is it actually? Here, square planar. Square planar. Right. Now the next one, what it is? The next one here, Cu tetramine copper. CuNH3, 4 times, right? This is 4 times 2 plus. So what is this actually? This is also square planar. Square planar. You please check it with that idea what I have given in the first questions. It will be easy for you to understand. BF3. So BF3, it is simple. Already you know very well. This is triangular planar. Okay. Triangular. Triangular planar. Right now, next one, this is a triangular planar. It is actually what it is. sp2 hybridization. I didn't mention all this. So here dsp2. This is dsp2, and this also PtCl4. It is actually dsp2 only. Cu sp2, both dsp2. I just mentioned first to complete that. I think you have learned, and then the same idea you just follow. It is very simple. Okay, NiCO 4 times. Okay, NiCO 4 times. So this is actually what it is. sp3 hybridization. Okay, sp3. The first question that only, right? sp3 hybridization. So this is actually tetrahedral. Tetrahedral. So what? How many compounds are tetrahedral? You know very well. So what are the compounds? So the first one, tetrahedral. This is the tetrahedral, and the next one, which is this is tetrahedral, and this is tetrahedral. So that means ammonium, it's a tetrahedral, and in this nickel, it is a tetrahedral, and the last one, CO, it is. These three are tetrahedral compounds. The rest of that, I think you have gone through. And this is very simple. How do we identify what it is? Geometrical point means, first and foremost, you have to go for oxidation state, and the second one, you have to find out weak field or strong field, and from that only you can identify whether it will pair up or not. And the next one, from that we can identify hybridization and geometry, and the next one magnetic property, and a lower spin or higher spin, and the last one Bohr magneton. Hope you got the clear idea about all these questions whatever I have got from this point. And seriously, students, whoever is listening, I'm really happy that you are spending your time, meaningful time, to observe this, and thank you so much. See, one thing, don't give up, because toppers are not born, they are trained. Always you practice, 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 practice makes the man perfect. Vivekananda told, no, Dr. Swami Vivekananda, try until you get success, and all the best for your bright future. And thanks for watching. In our next video we will see that the next day of what it is, JEE mains. And thank you for watching.